Today, we're diving into an idea that is going to completely change how you think about, well, thinking. It's a concept that shows how your brain is almost never working alone, especially when you're using the very device you're watching this on right now.
You know the feeling, right? You're just trying to get something done. You click a button, something totally unexpected happens, and you're just stuck. You feel frustrated, maybe even a little bit dumb, and you start thinking, ugh, I must be doing this wrong. It's something we've all been through.
But here's a thought. What if you're not the problem? What if the real issue is a flaw in the system's thinking? And I don't just mean the app on your screen. I mean the whole setup, the people, the tools, the entire process that's supposed to be working together.
And that brings us to this really powerful idea called distributed cognition. It's a new way of looking at things that shows us that thinking isn't some solo activity that's locked up inside our heads. It's actually a team sport.
So what does that mean exactly? Well, at its heart, distributed cognition says that thinking is spread out. It happens across a whole system. That's you, your computer, maybe some notes you've jotted down, even the people you're working with. So if you really want to understand how a task gets done, you can't just look at one person. You have to look at the entire system in action.
This quote from researcher Edwin Hutchins just nails it. He studied these super high-stakes environments, like navigation teams on giant warships and pilots in cockpits. And what he found was wild. They didn't need to hold some perfect, complete map of everything in their heads. Why? Because they were offloading a huge chunk of the mental work onto their tools, their charts, and each other. Their instruments were doing the heavy lifting, doing the remembering for them.
Okay, so if thinking is spread out, how do we actually analyze it? Well, that's where a handy framework called the resources model comes in. Think of it like a toolkit that helps us break down exactly where the thinking is happening in any system.
So, the model gives us 6 key resources or building blocks for getting anything done. And the cool part is, these can exist either inside your head, like a memory, or out in the world, like a checklist on a screen. Let's walk through a few of these to see how it really works.
First up, we've got a plan. This is just the sequence of actions you need to take to get to your goal. You know, like ordering dinner on a delivery app. The app gives you an external plan, right? It guides you browse restaurants, pick your food, go to checkout, and pay. The app holds that entire plan for you, which frees up your brain to focus on the important stuff, like deciding between pizza and tacos.
Next, possibilities. Sticking with our food app, when you look at a restaurant's menu, you're seeing every single thing you could order. That list is an external representation of all the possibilities. The system is showing you what you can do so you don't have to rack your brain trying to remember every option. It makes the choice way easier.
And then there's history, basically a record of what you've already done. Think about the reorder from past purchases button on that same app. That is a perfect example of externalized history. The app remembers your favorite order, so your brain doesn't have to. It's such a simple feature, but it's a really powerful cognitive tool.
Now this is where it gets really interesting. Look at how these resources actually change how we behave. On the left, you've got a chart wizard. It gives you a step-by-step external plan. It basically holds your hand and makes you follow its plan. But on the right, you have a standard dialog box. It throws all the options at you at once. This design forces you to have the plan in your head and to match your actions to your own goal. It's the same end result, but a totally different amount of mental work.
Now, to see why this is so critical in the real world, we're going to look at a pretty extreme example, NASA's Mission Control Center. This is a place where getting distributed cognition right isn't just about making things easy, it's literally a matter of astronaut safety.
So researchers took a close look at the job of the biomedical engineer, or BME. Their job is to monitor every aspect of an astronaut's health, all from the ground. And as you can imagine, it's an insanely complex role. They're juggling a constant fire hose of data in an environment where they're being interrupted like all the time. And get this is just wild. To solve one single tiny sub-issue, a BME had 21 separate conversations over phone or voice loops with 12 different departments. The thinking needed to fix that one problem was literally scattered across the entire organization.
This chart really shows you what their day looked like. BMEs spent 60% of their time just passively listening to voice channels, trying to soak up this constant flood of information. The whole cognitive system was just drowning in communication, which made it almost impossible to focus and solve problems.
And these are the specific breakdowns the researchers found. The system's organizational memory was just broken. You had informal knowledge, a quick idea someone had that was never captured, and the formal knowledge, the stuff in manuals, was buried and hard to apply. What did that lead to? people solving the same problems again and again from scratch.
So what's the fix?
Well, the answer isn't just to make a prettier interface. The solution is to design for the entire cognitive system.
Taking this human-centered approach means you start by analyzing the whole network, all the people, all the tools. Then you figure out where the really critical information lives. Is it stuck in someone's head? Is it in a logbook somewhere? Then you can build technology that actually helps that information flow, making it visible and easy to access, which takes a huge mental load off of everyone.
The thing is, these lessons from the chaos of mission control apply to literally every piece of technology you use every single day. And this way of thinking, it really changes everything we thought we knew about good design.
And that brings us to the biggest takeaway of all. The best technology doesn't just look good. It acts like an actual extension of your mind. It remembers the little details for you, it shows you all the possibilities, it keeps track of your history, and all of that frees up your brain to do the creative, important, high-level thinking. It becomes a true partner in how you think.
So I'll just leave you with this. The next time you use an app, a website, any tool at all, just stop for a second and ask yourself, is this thing making me do all the heavy lifting, or is it a smart system that's actually thinking with me?